Folks, welcome back. It's great to have you here. If you recall, yesterday we discussed rational numbers. I'd also like you to remember that the set of real numbers includes both rational and irrational numbers. So for those of you who are visual, think about your Venn diagrams that we created in class. You had two sets of numbers. You had your yellow rectangle and everything inside of it, which included all of the rational numbers. Then most of you, if you put your Venn diagram together the way we told you, had an orange rectangle, and that represented the rational numbers, and that was completely off on its own by itself. Okay, so they're two different sets of numbers. Since we remember that the rational numbers are any numbers that can be converted to fractions, it makes sense that irrational numbers are those numbers that can't be converted into a fraction. And actually, these are the decimals that go on forever and never repeat. For instance, on the screen here, in my lovely handwriting, we have the square root of 35. If you recall, in class, we discussed that the square root of any number that's not a perfect square is going to be an irrational number. For those of you who have calculators and you don't believe me, go ahead and check this. Okay, that decimal is going to go on forever and it's never going to repeat. Now, our first example of two is number 1. Explain why pi is an irrational number. You guys know, and you've been told for the last several years, that pi is an irrational number. That's why when the teacher says, folks, do you know what an irrational number is? Everyone shouts out, oh, it's like pi. It's like pi. Okay, but I need to know why pi is irrational. It's actually a lot simpler than it sounds, folks. First of all, let's think about on the back of our Venn diagrams where we put our definitions. What is the definition of an irrational number? The definition of an irrational number is an infinite, non-repeating decimal, or what we put up here. They are the decimals that go on forever and never repeat. And we all know that, without me writing it, pi is something like 3.1415927 blah 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 blah. Okay? So since we know that pi is this decimal that goes on for forever and ever and never repeats, this little symbol means therefore, you can give me a full-fledged answer other than, well, my teacher told me so. You can tell me that pi is an irrational number because, and maybe I'll get rid of that therefore, because it fits the definition of an irrational number. Okay? It fits it perfectly. Since pi is a decimal that goes on and on forever and never repeats, it is definitely an irrational number. This is a lot harder to do than it looks, folks. So once again, I'll ask you to forgive me. And hopefully you'll write a few more notes down than what I have here. Okay? A little more detailed. But you can hear what I'm saying, so you should be writing a little bit more specifically. One more time I'll say it. Pi is an irrational number because it fits the definition of an irrational number. It is a decimal that goes on and never repeats. Now, let me see if I can't get rid of what's on the screen and scroll down so we have some more room to work on number 2. Alright, remember you can pause this video if you need to. Number 2 says, graph the approximate location of the square root of 45 on a number line. Okay, my suggestion, let's use guess and check. So, if you all know your perfect squares, which I know most of you are gonna in the near future, that's gonna help you out quite a bit here. First of all, which perfect squares does the number 45 lie between? Well, you guys would probably, after thinking about it for a minute, come to the conclusion that square root of 45 is between the two guys right here, square root of 36 and the square root of 49, which we know this one to be 6 and this one to be 7. So we know that the square root of 45 has to fall somewhere in between. It's going to be a decimal. And if you recall, since it is the square root of a number, of a non-perfect square, it's actually going to be an irrational number. But it only asks for an approximate location. So, we know that 45 is between 36 and 49. Now, the question is 45 closer to 36 or is it closer to 49? It's obviously closer to 49. So we know the square root of 45 is going to be greater than, more than, 6.5, since it's closer to 49. You, once again, don't have to write exactly what I'm writing. I would encourage you to write out more of what I'm saying, okay? It's just a little bit more difficult for me to write. So that's why I'm not writing quite as much. Okay? So since 45 is closer to 49 than it is to 36, let's just lay a guess down. Let's guess, I don't know, 6.7. So we're going to guess that the square root of 49 is about 6.7. And how do we check that? Folks, we love to check things in math class. All you have to do is multiply. So 6.7 times 6.7, and let's see what we come out with. Most of you are probably going to go to your calculator because I know how you operate. Okay, as it happens, because I'm going to assume that we know how to multiply, here you have 44.89. I worked this out ahead of time. I can assure you of that. So 6.7 times 6.7 is very close to 45, which means we made a pretty good guess. For sake of time, I'm not going to guess. Since we're a little bit under 45 here, you could go to 6.8 just to double check that that's not closer than 6.7. But for sake of time, I'm not going to do that. I can assure you that what we have here, 44.89, is closer than what we'll get with 6.8 times 6.8. So, we have an approximation for the square root of 45. But we're not done. The problem says, please graph it on a number line. So let's come to the bottom here. Let's fill out our number line. 6.4, 6.5. Oh boy, this is difficult, folks. 6.6. I'm going to have to get a better writing utensil. 6.7. Normally you would label everything on the probably below the axis. But once again, I'm trying to, my writing is a little bit too big here. 6.9, 7.0. You really don't even have to go any further. Okay? So obviously it falls right on 6.7. Let's put it down there. And we're done, folks. It was that simple. There's quite a few steps in there, so if I were you, if you didn't get all that, rewind it, watch the last 3 or 4 minutes just to write down the process so that when you see this in class tomorrow, you can refer back to the process and you don't have to try and remember, oh, what did I see in that video? If you have the process right in front of you, it's going to help you a lot. It's going to save you a lot of time. Alright, so thanks for being with us, and we look forward to seeing you tomorrow.